Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is range product queries of powers. Now, the problem category is of medium level, and first of all, let us try to understand the problem. So, in the problem, the given input is an integer n, and there is another input which is queries, which is a two-dimensional data. This two-dimensional data has list inside it or array inside this, and every array or every list is composed of two elements. There is a left index, there is a right index. Now, the output which we need to give is we need to return an array answers which is going to be equal in the length to queries. So basically for every query or every data in query, there will be an output. So the length of queries and length of output will be same. In the output, we need to return an array or a list. This length should be equal to queries where answers of I is the answer to the ith query. Since the answer to the ith query may be too large, each answers of I should be returned with modulo of 10 to the power 9 plus 7. So basically we are given an integer n and queries. For every query, there will be an output, and the value of the output can be very large for a particular query. So we need to return the output, whatever is the output for a particular query is. For example, for 0,3, it is 64. So maybe the output could be too large. So we need to return it with the modulo of 10 to the power 9 plus 7. Now, how to build this output based on a query and what is the use of integer n, we will try to understand that now. So let me read the question first. So we are given a positive integer n. So let me write this. We are given n and it is a positive integer. And there exists a zero indexed array called powers. So now there is a zero indexed array powers and it is an array, right? It is composed of the minimum number of powers of 2 that sum to n. So basically in this particular array, we need to store powers of 2, but we need to store the minimum number of powers of 2 such that the sum of this array is equal to n. This is what this particular line means. Basically the array called powers is composed of the minimum number of powers of 2 that can sum to n, and the array is sorted in non-decreasing order, and there is only one way to form the array. So basically the array we are trying to create, the powers array, this array will be non-decreasing. It means it will be sorted in increasing order, and there is just one way to form this array. Now you need to understand that this powers array will be created by us based on the given input n, and the sum of the powers array will be equal to n, and the powers array will have the minimum powers of 2. For example, if the value of n is equal to 15, we can say that the powers array can be equal to 1, 2, 4, 8. The sum of this is equal to 15, and you will see that the numbers are made up of powers of 2. We can say 1 is 2 is to power 0, 2 is 2 is to power 1, 4 is 2 is to power 2, and 8 is 2 is to power 3, right? So these numbers are made up of powers of 2. Now you are also given a zero index 2D integer array queries. So now we are talking about queries where queries of I is left I and right I. Basically every query is an array where there is a left index and right index. Now let me try to explain you the problem with the example. So basically the given value of n is 15, right? So if n is 15, the powers array will be 1, 2, 4, 8. And right now we are using minimum number of powers of 2. For every query, we need to return an answer, right? So now we have n, we have powers. Now for 0, 1, what we need to do is, we need to trace all the elements which are from index number 0 to index number 1 in the powers array, and we need to multiply them or take the product. So it will be 1 multiplied by 2, right? Now this 2 mod 10 to the power 9 plus 7 will be equal to 2, right? So for 0, 1, the output is 2. For the next one, which is 2, 2, you have to trace all the elements from index 2 to index 2, which is 4 itself. So the product of just one number is 4 itself. And when we talk about 0, 3, we need to go from index number 0 to index number 3 and take the product of all the elements. So it will be 1 into 2, which is 2, 2 into 4 is 8, 8 into 8 is 64. So this is 64. This is how you need to find the output for each query. So our first task is to create the powers array. So let's not focus on solving the problem for each query. Let's focus on creating the powers array. How are we going to create the powers array? Now one of the mistake which can be done is you might try to create the powers array starting power of 2. Power of 2 starts from 1, which is 2 to the power 0, then 2, which is 2 to the power 1, then 4, then 8, then 16, then 32, and this will go on, right? Now, if you want to create a powers array for a given value of n, which is 15 as of now, so you might say that n is equal to 1 plus 2 plus 4 plus 8, right? Which is fine. This is right as of now. But what if the value of n is not 15? If n is equal to 14, then what will happen? Then this will be 2 plus 4 plus 8, right? 2 plus 4 plus 8, this will be equal to 14. Now you will have to notice a very important thing here. When we talk about 14 or when we talk about 15, they are starting with different powers of 2. If you want to create a powers array for 15, you have to start from 2 is to the power 0. But when you are doing it for 14, you have to start for 2 is to the power 1. Now you can also do it in this way. 14 can also be equal to 1 plus 1 plus 4 plus 8, right? Here you can see that this will be equal to 14. This will also be equal to 14. But the problem says that your powers array should be composed of the minimum number of powers of 2. So here we are using 4 number of powers of 2. 2 is to the power 0, then 2 is to the power 0, then 2 is to the power 2, and 2 is to the power 3. Here we are using just 3 powers of 2, 2 is to power 1, then 2 is to power 2, then 2 is to power 3. So obviously this is something we have to ignore, right? We have to create the powers array in such a way that we are using minimum number of powers of 2. Now one of the best strategy would be, whenever you get a number 14 or 15, or let us say you get a number 16, right? If you get a number 16, you just need to create the powers array first, right? So you can say that your powers array will have just one element, which is 16 itself, because this is 2 is to power 4, an exact power of 2. And now the sum of this array is equal to 16, right? And we have to utilize minimum number of powers of 2. So even though I can say that this can be equal to 8 comma 8, which is also equal to 16, 8 plus 8 is 16, but this is using 2 number of powers of 2. So now since we are clear that we have to create the powers array of powers of 2, and it should be have minimum number of powers of 2, what should be our strategy? See, one of the simple strategy is, since we have to minimize the number of powers of 2, start with the bigger number. And when we say bigger number, start with that number which is the biggest but not more than 16, and which is a power of 2. So when we talk about 16, what is the biggest number which is the power of 2 but not more than 16? Then it is 16 itself, right? 16 is not more than 16, it is equal to 16, and it is a power of 2. So what I can do is I can say I got 16. How much more I need? I need that this particular array should have a sum of 16, right? I got 16. How much more I need is 0. I don't need any more, right? So I can stop here. But when we talk about 15, what is the biggest power of 2 which is not more than 15? 16 cannot be the power because 16 is more than 15. So it has to be 8, right? Now once we get 8, how much more do we need? See, the thing is, our target is the array should have the sum as 15, right? I need 15. I got 8. I need 7 more. Let's do the same thing. What about 7? What's the highest power of 2 which is not more than 7? So it is 4, right? So once we get 4 more, I need 3. What about 3? For 3, it will be 2. 2 is the highest power of 2 which is not more than 3. So I got 2. Now I need 1 more. What's the highest power of 2 which is not more than 1? It is 1 itself, right? So we got the array for 15. And the reason for starting with the highest element is we need to minimize the number of powers of 2. So if you start creating your array with the highest power of 2's, then you will minimize the number of powers of 2, right? And obviously you cannot take the power of 2 which is more than the number itself, right? Because then you will never be able to get a sum equal to 15. It will always be more than 15 or more than n. Let's see another example for 14. For 14, what's the highest power of 2 which is not more than 14? It is 8, right? Once I get 8, I need 6 more. 14 minus 8 is 6. For 6, what is the highest power? It is 4, right? The highest power of 2 which is not more than 6 is 4. Now we need 2 more. So it will be 2. So we got 8, 4, 2. This is going to be the logic to create the powers array. So first let us create the powers array. So for that what we can do is let's create an array called as ARR, which is equal to an array or a list. Now while our n is not equal to 0, what we need to do is we need to find that particular number which is a power of 2 but not more than n, right? So as of now, let us say n is equal to 15. If I take the log of 15, because the thing is log is specifically made for this purpose only. If you take the log of 15 with the base of 2, this will be somewhere between 3 point, I would say 9 something. Now if I want to find that power of 2 which is not more than 15, then it will be 2 to the power 3 which is 8. So I have to find the log of my number n and then take the floor value of this, and then I have to say 2 is to power that particular floor value, right? So first let me find the log of n with the base of 2. So I can say log 2 for n. Now I need to take the floor of this. I need the lower bound of this number. Now I want to find 2 is to power this particular number. So I can say power, let me call the power function, and I can say 2 is to power whatever is this number, right? And let us say this is equal to p. P is equal to this number. I can get rid of this now. Once I get a number p, what I can do is I can say ARR dot append the number p, and n is equal to n minus p. This way, once I get p, I will reduce the p from n so that next time I have the updated value of n. This process will stop when the value of n is equal to 0. That is, we don't need any more power of 2's. If I print the value of ARR as of now and run this, you will notice that we have the ARR created. We have the powers array created. For the value of 15, the powers array is 8421. For the value of 2, the powers array is just 2. Now, one other thing which you will have to notice is the powers of array should be sorted in non-decreasing order. Right now, it is in decreasing order. It is not in non-decreasing order. So what we can do is we can actually reverse this. After we are out of the while loop, I can say ARR is equal to ARR of colon colon minus 1, which is actually going to reverse my array, right? Now my next process will be to actually create the resultant array or the answer array, which is actually going to be an output for each of my query. So if I have 3 queries, my output array will have 3 answers. So let me create an array. I can say result is equal to an array. And since I have to make sure that every answer should be returned with modulo of 10 is to power 9 plus 7, let's create another variable 10 is to power 9 plus 7. I will append my answer in this result, and while appending, I will take the mod of that particular number with this mod variable. Now to get the answers for every query, I can simply run a loop. I can say for left comma right in queries. Basically what will happen, every query is a list, right? A list of two elements. So whenever this list is going to be looped in, the left will store the left value, the right will store the right value, right? So now I have the left index and the right index for each query, and now I can run another loop. I can say for j in the range of left to right, right? Now I can say right plus 1, as we have to run for the loop from left to right, and I can say my initial result is equal to 1, because if you multiply any number with 1, the number is not going to change, and we basically need to find the product of all the numbers between this range of left I and right I, right? Now I can say that init is equal to init multiplied by arr of j, right? I want to fetch each element between this range and I want to multiply this, and after I am out of this particular loop, I can say result dot append. I can append the result, and I can say let me append init and take the mod with mod. This is going to solve my problem, and I can say return the value of result, and when you will run this, I think the sample test cases will be passed. Yes, it is passed, but I think it will give you time limit exceeded error. Reason being, it is a medium problem. Okay, it is not actually giving me time limit exceeded error. That is surprising, but that is good that we are able to solve the problem. But the runtime is fine. The memory used is not so great, which is fine. We are going to improve this. But guys, this is a brute force solution. Even though we have created the powers array, the ARR array, in a very optimal way, in a very smart way, this process is brute force. We are just running the loop for every query from left index to right index, which is a brute force way to solve this. There is no extra logic, there is no understanding here. See, the thing is, what I would suggest is you have to create a prefix array. This prefix array will store the product of the powers of 2's initially, so that you don't have to run a loop from left index to right index to find your answer. What I want to say here is, once this array is created, let's convert this array into a prefix array. What I mean by this is, see, the thing is, if my array for n equal to 15 is 1, 2, 4, 8, right? Now if I want that, if my query is 0, 3, I have to go from index number 0 to index number 3, and I take the product of 1 multiplied by 2 multiplied by 4 multiplied by 8, which is equal to 64. Right now I am doing this process. I am actually trying to multiply each of my numbers and then appending my result. Instead of this, what we can actually do is, since we are trying to find a product, we can append a number 1 in front. Now this is something which will be appended irrespective of whatever is my original ARR is. And now if you will notice here, the indexes of your powers array or your ARR array is going to change, right? The one which you added is at index 0, and other numbers are at index 1, 2, 3, 4, right? These are the indexes for other numbers. Now if you talk about index number 0 to index number 3, this is actually equal to index number 1 to index number 4, right? As of now, it is fine. But how it is going to help us is, I can convert my ARR to prefix array. The first element will remain same, which is 1. The next element will be equal to the product of the current element and the previous element. So 1 multiplied by 1 will be equal to 1, which is fine as of now. 2 will be 2 multiplied by 1, which is 2, again no problem at all. But this will be converted to 8. This will be 4 multiplied by 2. So this is now 8. And this will be converted to 64, because this will be 8 multiplied by 8, which is 64. Now let me tell you how is this going to help us. See, the thing is, this number is actually made up of product of all its previous elements and this element itself, because this has come from product of the 8 and 8, right? This 8 is made up of product of the current number and all previous elements. This 2 is made up of product of current number and all its previous elements. Similarly for 1, and this is the one we added explicitly, right? We added 1 because if you multiply a number with 1, nothing is going to change. But how it is going to help us is, if you want to find out for index number 0 to index number 3, you now basically need to find out from index number 1 to index number 4, right? If you want to find out the product of all numbers between this range, index 1 to index 4, but you already have the product of all numbers between index 0 to index 4, right? It is at index 4. At index 4, you have the product of all numbers till index 4. I have to find the product of all numbers till index 4, not including the index number 0, right? So I could simply say that if you want to find out for 0, 3, it will be whatever is at index number 4 divided by index number 0, because that will be product of all numbers between this particular range from 1 to 4. Let us say you want to find out from index number 1 to index number 2, which is 2 and 4, right? This will be equal to 8. How can you find this? If you want to find out for index number 1 to index number 2, this is going to be actually equal to 2 multiplied by 4, which is equal to 8. If you talk about this particular query, since we have already added one element to our array, this particular query actually means that what is the product of all numbers between index 2 to index 3, right? Our original array was 1, 1, 2, 4, 8. At index 2 we have 2, at index 3 we have 4, so it is 2 into 4, which is equal to 8, but we have converted our array to a prefix array. So now at index number 3 we have 8, right? Now if you want to find out from index 1, 2, you have to search at index number 3. At index 3 you have 8, right? At index 3 you have all the elements multiplied from index number 0 to index number 3, right? So we have all the elements which are multiplied from index number 0 to index number 3. So let me store it here. At index number 1, you have the elements which are multiplied from index number 0 to index number 1, right? So if I divide the element which is at index number 3 with the element at index number 1, this will be equal to dividing the product of all the numbers from index 0, 1, 2, 3 with 0, 1 index number. So this 0, 1 can be eliminated, and this is actually equal to 2, 3. That is the product of all numbers from index 2 to index 3. Since we are trying to find out for 1, 2, and after adding the element 1 here, this is actually trying to find out 2, 3, and we are able to find out 2, 3. So this is how the prefix array is going to help us solve this particular problem in an optimal way. So what we can do is, before we reverse the array, I can say array.append 1, and now I can reverse this. And now let me try to create this array in a prefix array. I can say for I in the range of from 1 to length of ARR, every element at index I of ARR will be equal to ARR of I multiplied by ARR of I minus 1. Once this prefix array is created, I don't even need this init. I don't need this extra loops. I can simply say that result.append instead of init, or what I can do is I can say init is actually equal to ARR of right plus 1 because we have added one element here, so indexes are shifted, and this is divided by ARR of left. I think this should do it. Let's run the sample test cases. So yes, these are passed. So you can see the code right now. We got rid of an extra loop, and now if I submit this, this should pass all the test cases, but in a very optimal way. So you can see the runtime is improved. The memory used is still okay. I mean, we are now using extra memory. If I tried submitting this again, I can see that the runtime is fine, the memory used is fine. So I think this particular code is a very efficient code, especially for runtime perspective. For memory used as well, this is fine. So we have solved this particular problem in a brute force way as well as in the most optimized way as well. So guys, I think that's it for this video. If this video has explained you everything in depth which you should know about this problem and the solution approach, then make sure that you are hitting that like button, and I will see you in the next video. I want to see you in the next video. Thank you for watching this one, guys.